Can everybody see it? I mean, visible. Am I audible?
Yeah, it's visible and you are audible.
Yeah, thanks. So our project is based on the using the AttnGAN, where we have to implement the text to the image. So my mentees are Vishnu Modi and Sranav Das. So I think both of them are working on under the project too. The motivation. So what are the motivation that we choose, or we choose the project text to image generation, is that it's usually this is the one of the basic creative of the deep learning, where we are using the text to generate the image. So it's very creative, and I think this is the I think by using this type of deep learning application, we can create a comic books, or we don't need any, I mean, it can be replaced by the designer. It can. So I think these are some of the motivation where we usually use text to image generation. And before going to text to image generation, let's discuss about AttnGAN, because the main concept of this using is the using the AttnGAN. So AttnGAN is here is two different component, like encoder and decoder, where decoder used like as generator. So generator is nothing but it's generate some image like this one. So we input X to the encoder and it's produce some labels, and that labels go to the generator, and also we are given by the noise, it creates some labels, and that is goes to the encoder. And over here there is two different type of label. One is by the real image and one is by the generator image. So and the loss function is the GANs, the AttnGAN have three different losses. The losses of adversarial, the losses of condition, and the losses of entropy. So these three are different losses. So this is the basic concept of AttnGAN. Now let's move to my project, which is Stack Generative Network for text to image. So over here, there's main two different stages, stage 1 GANs and the stage 2 GANs, where the stage 1 GAN is like a painter try to paint the whole picture. Before he draw whole the picture, he just draw some overall, like draw some boundaries, basic colors. So like this one, stage 1 GANs try to get some basic shapes, basic colors, and basics, a description from the text. And he also draws some low resolution image. So stage 1 GANs produce 64 into 64 pixels of image, and after that there's stage 2 GAN, which is help to correct the low resolution image that is generated by the stage 1, and that is completed by the stage 2 GAN, where he also got some text description from that text, and it's produced the high resolution image into 256 into 256 pixel. And you can see the stage 1 image and stage 2 image, where if you see this example, this bird is blue and white and has a very short beak. So on the stage 1, it doesn't have that much pretty sharp images, but over the stage 2, it's pretty good. I mean, it's make a pretty good generation and a good quality of image. So what are the architecture of the this application? So over here, this is the basic, the main architecture of this project, where there is some condition augmentation, stage 1 generator, stage 1 discriminator, stage 2 generator, and stage 2 generator. So let's discuss the one by one. So why we use the condition augmentation? So we use condition augmentation because we usually, when we try to encode this bird, this text into the vector word to vector dimension or a Gaussian distribution, there will be so spread, and the generator face the problem to training. So that's why we use the condition augmentation, which have to maintain the sparsity of the vector to embedding. So over here we use these callback labels divergence, which usually help to measure how one probability distribution is another distribution. For there are two different probability distribution. One is our main text encoder, and another one is a noise encoder. So if you see this picture, this is our text we encoded into, and the embedded is we usually use the pretrained embedding. And this is the noise we give into the, and we produce the C. So this is C is the new new distribution. And after that, the stage one, when the stage one got the C from the earlier condition augmentation, and it's concat with the noise, and it's tried to upsampling, and it's generate the 64 into 64 images. So right now 64 images are not that much good and not that much clear, and it's also used the condition. So this is the real image which are taken from the real distribution, and this is the image that has been generated by our generator one, and we downsampling it again, and then we finally, and we use this text embedding without taking the condition augmentation over the discriminator, and we predict whether our image is good or bad. I mean, our image is true or not, 0 or 1. So here we use the condition GANs also, and we use the NLP, I mean, for embedding when we have to convert this text into the vector. So these are the losses. The losses are mainly same as the basic vanilla GANs, like entropy of real image and fake image. Real image, this I node is the real image, and T is the text description is taken from the data, and Z are the noise. And after that, GAN one, the image of that goes to the GANs to generation. So, and we also here we use the same condition augmentation over here, because over the GAN 2 stage 2 GANs, they use the same condition augmentation, but they did not use the noise, because it's assumed that randomness has already been preserved in the S0. So here, instead of Z0, we use the S0. This is same as the noise in the stage 2 GAN. Over here, the same procedure we follow, but over here we use the resulted block for the better features extraction and for better result. And we, after sampling, and we produce the 256 into 256 real image, which is far better than the stage 1 GAN generator. And we use the same condition, our real image, and it goes to the downsampling, the same procedure, same again into the stage 2 discriminator. So this is the overall of what text to image generator by using this tag. Again, right now this topic is one of the most, I mean, hot topic in the deep learning field, and there's lots of, I mean, architecture where right now they use the attention GAN for the text to image generation. So this is the basic architecture of how overall GANs is produce the text to the image. And thank you. And if you got any question, you can ask text